Have you ever wondered how many other civilizations could be living in our galaxy? Here's how you can calculate it using the Drake equation. First theorized by Frank Drake of Cornell in 1961, the Drake equation allows us to calculate how many extraterrestrial civilizations may be active at any given time by multiplying a base number by a series of fractions until you are left with a final estimate. Allow me to take you through the calculation and show you how it works. Start with the number of stars in our galaxy, which is currently estimated at 400 billion. Then, multiply that number by the fraction of stars that have planets. You can be as conservative or liberal as you like here with the fractions. It all depends on what you think is likely based on the evidence. For our experiment, let's say that only a quarter of those 400 billion stars contain planets, bringing us to 100 billion potential star systems. Now, in each system, how many planets are suitable for life to develop in the first place? So far in our own solar system, we only know of Earth, but there was and still is potential for life on Venus, Mars, and even Jupiter. The moons of Jupiter and Saturn, namely Europa, Enceladus, and Titan, are also suitable candidates. This being said, let's keep our estimate down to 2 habitable planets on average per system, though you're welcome to change your own calculation if you think the number is higher or lower. 100 billion times 2 brings us back up to 200 billion potential worlds with life. And on how many of these worlds does life actually develop? Let's say half again, which brings our running total to 100 billion planets where life has arisen at least once. And out of those worlds where life actually develops, on how many does intelligence and an extraterrestrial civilization emerge? The calculation gets trickier here, as there is a lot of debate over how easily a technological civilization comes about. Many individually unlikely events in our history had to occur for our species and technology to emerge, which makes it difficult to know which event in particular was hardest to overcome. Given these circumstances, let's say that intelligence emerges on 1/10 of those 100 billion worlds, and a technological civilization emerges on 1/10 of those planets with intelligence. Our total is now 1 billion worlds on which a technological civilization has developed at least once in its history. We now come to a difficult part of our calculation where we must estimate the length of time that a civilization is actively transmitting signals into the cosmos. For example, humans have only been sending radio signals into space for less than a century, which is the blink of an eye relative to timescales ranging from millions to billions of years. We could easily miss another civilization by just a few hundred years if our overlap is slightly off. We also have come close to destroying ourselves using nuclear weapons, and still have the power to do so. Other civilizations may face the same dilemma as well, and it is not entirely out of the question that we may still destroy ourselves if we're not careful. If this is a typical case, the odds of 2 civilizations coexisting are very slim, and we may very well be alone. Consider the alternative view, however, that we overcome our challenges as a species and create a bright future for our civilization. Suddenly, the amount of time that we remain transmitting and searching could turn from hundreds of years to thousands or millions, even billions of years. And if we do so, I think it's very likely that we will come into contact with others who have done the same. My name is Kes Lippert. Subscribe if you've learned something new.